All right, we're going to look at a couple examples from section 1.2. I think most of this section you can get through, but there are a few in here that kind of pop up out of the blue. So with question help, in my math lab, maybe it makes sense. But in the textbook, let's look at number 14 and number 29. The directions are to find the slope and the equation of a tangent line to each of these graphs at those given points. So the graph of y equals x squared, right? We know that you don't want to graph each of these, but I want to provide a quick visual here. We know y equals x squared, very rough sketch, is a parabola, does something like that. So at this point, negative 2, 4, back to up 4, we know that that's on the graph because if you check it, right, this is x and this is y. 4 equals negative 2 squared, 4 equals 4. Right, it is definitely on the graph. But anyways, the slope in the equation of the tangent line at that point, right, where they're talking about, remember, a tangent line only hits that graph at one point. Right, it kind of, think of skimming it here. So at negative 2, 4, we could see the slope on that line I drew should be negative, where if we go to the right, let's say the point 1, 1, use a different color here. At that point, we could see that this slope in this line is positive, right? And as we move further to the right, it actually becomes steeper and steeper. Regardless, to do this problem, they give you the fact that the slope of any function of y equals x squared is equivalent to just setting m, right, for slope, is 2x. Later we'll learn that this is actually called a derivative, but for now they give you this formula. It's kind of weird. And just kind of blow past this. So if the slope is 2x, that tells us take our x value and multiply it by 2. So for number 14, the slope then is 2 times negative 2, which is negative 4. In order to write an equation of a line, I'm going to write this equation up here. So slope we know is the m, and switch colors here. Equation of a line in point slope, since we're going to use this a lot, y minus y1 equals m x minus x1 in parentheses. Okay, that is an equation you will need to memorize if you don't have it already. Okay, we will use that all semester. So we have x and y above. So just plugging in that formula, y minus y1, y minus 4, okay, this is the equation, equals m, right, we just got was negative 4, x minus x1, which is negative 2. Now typically our answers we want in the form y equals mx plus b, so we will distribute and finish simplifying this. Distribute negative 4. Negative negative becomes a plus. Negative 4 times a positive 2 is a negative 8. Once we add 4 on both sides of the equal sign, we end with y equals negative 4x minus 4. Okay, this is the equation of that line I drew above the rough sketch. And glancing at that, that looks about right. The slope looks about negative 4, right? It's pretty steep. And the y-intercept of rough sketch, it is somewhere down there at about negative 4. Always kind of visualize the accuracy of your answer. Okay, moving to this next one, y equals x to the third. If you don't remember, again, you don't have to graph these. I'm just simply giving a visual. But if you don't remember what a cubic looks like, it does something like this. So at this point 2, 8, we could kind of visualize, right? We should get a very steep line. Now, the slope for this function for a cubic is different than a quadratic, the x squared. The slope, and it's in your book, of y equals x cubed, the slope is m, is actually 3x squared. At the end of this video, we'll talk a little bit more about that. For now, let's go and wrap this problem up. So we take our x, which is 2, and we, whoops, erase that, and we plug it in 3x squared, so 3 multiplied by 2 squared. So 3 times 4 by order of operations, which is 12. Now we go back to the same equation of a line, y minus y1, so y minus 8, right, because we have our x and our y above. 2, 8, so y minus 8 equals 12, x minus 2. Distribute and combine like terms. Let's get in slope-intercept form, y equals mx plus b. Add 8. And again, kind of looking at the graph, the y-intercept probably is way down there at -16, so that looks believable. The slope is 12. That also looks believable. All right, to wrap up this section and take a glance at future sections. When we said the slope at a point, we also have this word, let me change colors here, let it stick out. We also have this word called derivative. Okay, if you see derivative, slope, rate of change, moving forward, this is what we do in Calc 1. It is almost every problem. If you're unsure what to do the derivative. Okay, for these monomials we had above, notice for, I'm going to call it derivative even though we said it's a slope equation. Notice the x squared became 2x, right? The derivative of x squared is 2x. What we did is we brought this exponent down and subtracted 1. So bring the 2 down, and that's x to the 1, which we don't need to write x to the 1, right? And x to the third for the next one. We bring that 3 down, and we subtract 1. Okay, any monomial such as that, if I said x to the 7th, the slope at any given point, bring the 7 down and subtract 1. Alrighty, that should do it for section 1.2.